Dirk is in our motion product management, and he knows everything what is accelerated needs to be decelerated at some point. And when you decelerate something, motor turns into a generator, and you have to get rid of the energy. Braking resistors are one way, but there is a better one, right?
That's right.
So we can use our power regeneration modules. Yeah, we call them universal power regeneration modules. What does this mean?
That does mean that you can use it with our multi-axis system AX8000, with our ZervoDrive AX5000, and in addition with third-party devices.
Yeah, okay. But if there is a situation where I'm maybe very much accelerated, I need to decelerate now a lot, and I have a lot of energy which I need to feed back. How can I do this? Because this is one device, yeah?
Yeah, so it's quite easy. You can add as many regenerative units you need, and you can use it in parallel, so it's no problem to extend the system for the need of the machine.
Okay, so a modular system, a scalable system.
Yeah.
And at what point in time or at what point in the application do we actually start feeding back the energy into the grid? Because it's actually quite nice to have a little bit of energy in the DC link, right?
Yeah, the best way is to store as much energy inside the system as possible.
Yeah.
So we store all energy inside the DC link, and then the voltage goes up, and then shortly before the overvoltage threshold of the devices, we start the regenerating.
Okay. And when I've learned about the MX system, which we introduced only a few years ago, I got the feeling that a very important part in automation is housekeeping. Yeah? So that's filters, for example, making sure that you always have a nice seamless curve. How can we ensure this? I would have to do the question again because I got to know that my microphone wasn't working anymore. So the question is about the point in time. The question is about the. Is this one working? Wonderful. Okay, last question, because maybe there is so much power regenerated here at the moment that it's disturbing a little bit the radio frequencies. How do we make sure that the current which is going back to the grid is also in a nice sinus curve?
Yeah, so normally you make some mains desertion if you have a block shape regenerated. We don't have the block shape, we have a sinusoidal regenerative. And so we avoid to have mains desertions.
Okay, so we make the housekeeping a little bit easier. So a perfect technology if you want to decrease your bill. Thank you very much for electricity at the end of the month.